In this video we'll be dealing with using textures in Cycles. The main reason why I think Cycles is so powerful is because it allows us to do a sort of photoshopping or compositing of our materials. Basically taking in several inputs, doing some stuff to them to create a unique texture that we then plug into our shaders, and then we use some more textures to control how those shaders are mixed together to get our final material. As you can see, the textures available in Cycles are very similar to those in Blender Renderer. We've got image textures, Musgrave, Voronoi, and Noise, which is the same as a cloud texture in Blender Internal. To mix two textures together, we just need to add a Mix RGB node. Notice that this isn't the same as a Mix shader, we're just mixing color values here, not actual shaders. However, it works the same way. We have a fact value that controls the ratio between two inputs. On 0 we don't have any of the bottom input, but as we increase the fact we get more and more of that bottom input until we reach 1, where we can only see the bottom input and the top is no longer visible. The mix node also has a blend type, which is the same as your blending modes in Photoshop or GIMP or the compositor. It's mostly just basic math functions such as adding color values together or multiplying them or whatever. It's perfectly fine to just play around with these modes until you get what you want, but if you understand them and how they work, what they're for, you'll be able to create much more advanced shaders much quicker. We'll be using this node a lot when we get to the Ninja in the next few videos, so don't stress about it now. The other option on the mix node is a clamp checkbox. Now, you might need to think outside the box for a second. Traditional image formats like JPEG and PNG usually have 256 colors in each of the red, green, and blue channels. Black is represented by 000 in the RGB channels, and white is 255, 255, 255. But what happens when we add white to white? We will get the color of 510, 510, 510, and even though our computer screens can't show us this color, it'll just look like white, it's still stored as that big value. This is the whole idea behind HDR images. They store colors even brighter than white and even darker than black, which is why we can use them to make instant realistic lighting. This is useful sometimes when doing heavy manipulation of textures and even necessary when getting a very detailed Musgrave texture. But sometimes we don't want these super bright and super dark values, and they can often cause strange artifacts in our renders if we don't keep them in check. In such cases, all we need to do is check the clamp box in the mix node, and it'll set all those super bright values to just a regular white. Next, you'll notice all of these textures have a vector input, which is what we use to control how the texture is mapped onto an object. By default, all procedural textures are mapped using generated coordinates, and all image textures will use UVs. If we want to change this, we just need to add a texture coordinate node and plug in one of the outputs. If you want to translate, rotate, or scale the texture, you just need to add a mapping node. The cool thing about texture coordinates in Cycles is that the X, Y, and Z axis of the texture coordinates are actually shown as red, green, and blue colors, and then we can manipulate these colors, which will in turn change the mapping of the texture. So, for example, we could use a noise texture to warp the coordinates of a brick texture, making the lines of the bricks more distorted. Or maybe we can remove the obvious repeating patterns when we use the same texture on lots of objects by adding a random value for each object to the coordinates. Again, this is just a quick overview. We'll actually use this theory in practice later on the Ninja. Now, finally, now that we have our heads in a nice mathematical space, let me tell you about something called masking. Now, most properties of nodes will actually have an input socket, meaning that instead of controlling that value by hand, we can plug a texture into it. For example, if we have a mix shader that's mixing a diffuse and glossy shader, we can plug a texture into the FAC. This is how a traditional specular map would be used, but it's far more powerful than just that. One thing I do very often is mix a texture together with a gradient of sort, usually a baked ambient occlusion map, such that it makes a harsh pattern on the corners, that I can then use to mix two more textures together to create the appearance of dirt. This is then used later again as a mask for the mix shader so that the dirty areas are less reflective, and then again for the bump map so that the dirt is more pronounced on the surface. Now that's it for this video. I know it's a lot to take in, but don't worry about it. There will be some good practical examples coming up in the next few videos. Speaking of which, in the next chapter we'll cover some basic shading principles in more detail while making some materials for the Ninja as examples.